we can come up with more than one Lewis dot structure for a molecule that are not equivalent. So for example, if we follow the following steps that we've done earlier to obtain a Lewis dot structure for beryllium chloride, we can obtain the following structure where we'll follow up to step 5. And if we continue to step 6, to give beryllium a full octet, we obtain the following Lewis dot structure. Well, we basically took a lone pair of electrons from each chlorine to form an additional bond. Now to determine which Lewis dot structure is the most likely correct, we introduce the concept of formal charge, which is equal to the number of valence electrons minus the number of free electrons and minus the number of bonded electrons on 2. So from the periodic table, we know that chlorine has 7 valence electrons, and we have 6 assigned electrons, and then minus 2 electrons per bond, divided by 2. So basically the concept of formal charge assumes that those electrons are shared equally between the bonded atoms. And similarly, the formal charge on the other chlorine atom is 0, and beryllium has 2 valence electrons from the periodic table, minus the free electrons, and then minus the number of bonded electrons, which is 4 in this case, on 2. So the goal is to get a formal charge of 0 for the central atom. So this is the likely correct Lewis dot structure. And I'll leave it for you to verify the formal charge of the atoms in this structure, and you'll find that the formal charge of the central atom is not 0.